Hi friends, in the series of DSA interview questions and answers, we will be covering the interview questions mostly on the string, list, trees, and graph, and all the standard problems we will be covering, including the recursive problems, and
That
of course the
particular index.
mathematical
Let me put
problems
some white
also.
space so
And
that
it will be mutual learning. So
now
let's hope for the
suppose
best and let's start.
we want to remove element at suppose we want to remove element at this element we want to delete. So what will happen is, if we want to delete this element, let me circle it. So yeah, if we want to delete this element, right, so what we will be doing is, this will point to this and this will point to this, right, and this element will be deleted. So this element will get deleted. Yeah, so we will remove this element. Okay, so this element is deleted now. So let's undo that and understand the logic how we can write that. Okay, so quickly finish this one. So what we will be doing is, almost same logic will be there. Only thing is, what we will be doing is, so index should be start from negative. And why index should start from negative, I will tell you the logic. Because we should be one index behind. If we want to delete this, we should point to this one. We should stop at this one and we should say, okay, next we will take it into some dummy node or temp node, and then what we will be doing next. So that's why we should stop at this node. So that's why there should be for d2 we should stop at d1. So index should be 1 minus. So what I should do, int index, first thing first, index reached equals to minus 1. I will start from -1, and then again we will have the same logic of checking. So it should have input as remove element at index, should have input index, right, int index, which element it want to remove. Now what I will be doing is, I will put the same condition here, and yeah, and I should write this downside. First thing should be the why should we initialize this if it's not if it's invalid index itself. So let's do that first, and then custom node iterator, again same thing should be there. So let's copy this whole thing, so this will make our work faster. Oops, what I did, copy and paste it. So I will remove this, I have already. So custom node iterator is there, it's pointing to head. Index reached, index, suppose we want to delete the second element, so index should be so this is first, which is element is index is first, so index should reach to 0th element, right? So index reached is index -1. Okay, and then custom node iterator dot get next reference is equals to node, and then what we will be doing is, so this is the node which should this is the node which is just one step behind the target node. Means this node we should delete, and this is the index -1, the node which is just one less than the index of the node to be deleted. So I should collect it into the, well, let's say index, let's say I will, yeah, int index, sorry, custom node iterator. So suppose I want to delete this node itself, in the head first node itself. So sorry for the background noise. Index is -1, right? Index reached is -1. This should be the index 0. So 0 minus 1 is minus 1, minus 1 is less than minus 1, no, so it will come out of this and automatically. So we will get the list which is pointing to the reference. So list, we will get this head itself, right? So list which is pointing to the target node. So let me say custom node pointer to target, right? Because the previous node will point to the target node, pointer to target node, and then equals what it will be. It will be custom node iterator, right? And what we will be doing is this next should go to this one, and then next, and then there should be one more thing, custom node no now there should be two, there could be two conditions. So let's jump to the let's first write the logic, and let's first let's first understand that there will, how can be the two condition. It could be the last and it could be the second last, right? Only these two conditions could be there. Other checks we have already kept there. So let's understand first. Suppose it's the D3. Suppose we are deleting this itself. So next to next will not be there, right? So it should become the last node in that case. Okay. So let put that logic first. So what I will be doing is custom node node next to target, right? We should write the proper name, then we can, first thing is we should write the proper name, then we can minify the naming. Also we can give some sort convention. So next to target node is pointer to target node dot next reference dot get next reference. So now we should closely see what we have written. So there could be a condition when this get next references sorry I got little cold, please excuse me for that. Yeah, now so there could be a possibility that this is null, and then we will get a null pointer exception. That means we can't get null dot get next reference, right? Something like that. So there should be some condition check, and that's why I wanted to stop it here. And what we will be doing is we should break it into two cases. Now I should remove this, and I should do target node, and let's write it into this one, new line, and let's paste back. And then what we will be doing is pointer to target nodes, and then there will be target node itself, custom node. So custom node target node equals to pointer to target node dot get next reference. So so this is the target node, means this is the D3 node, and now we are considering when we want to delete the tail element itself, last element itself. So this is the target node, and we want to, target node is D3, and we want to delete the target node itself. So get next reference is target node. If target node itself is null, which should be invalid, so what we will do is we should directly return head of the list, right? It's invalid case, it will though never fall into that case, but for the safer side I have just done that. Okay, now let's put some place, empty place. Now we will go to the next reference, target nodes dot next. Now let's begin with the tail condition. If it is a tail node, what we will be doing is, if it is a tail node and suppose we want to delete D3 itself, D3 element itself, so target node will be this one, right? Target node is D3. So target node dot get next reference will be null. So target dot get next reference will be null. So target node. So target node dot get next reference will be null, means node next to target is null, it will be right. So if it's, then it will be tail node. If node next to target is equals to null, what we should do is, there will be no condition to set it. There will be no condition like we should point this to any other or this to other node, right? There will be no such condition. So what we will be doing is, we will just pick this d2 node and we will say next is equals to null, and that's all we should do. Pointer to the, so what we will be doing is pointer to the target node. Yeah, pointer to the target node, which is pointing to the target. Pointer d2 is the pointer which is pointing to the target node. So pointer to target node is equals to dot set next reference equals to null. I will do null, right? And for the easy thing, we should do ourselves, we should do this one also, we should do null itself. Okay, we should so that it is available for the garbage collection. So the we should do target node dot get next reference dot set next reference null, and target node dot set previous reference is equals to null. This how we will completely lose the links with the previous node and the next node, and made it eligible for the garbage collection. And target node dot set data equals to null. So we have completely removed and all the connections of this node, and we have said the now it's this is the good way, we should always do like that. And then next previous reference, so now the previous is d2, and then the set next reference should be null, so next is nothing. And then what should happen to tail? Tail should be tail should be equals to, tail should point to this d2, right? D2, so this is tail. Now tail should point to this one if we are deleting d3, right? So tail should be pointer to target node, that's all. So tail pointed that, and then we can remove the head. Return, what is the head? Custom node, return head, sorry, yeah, return head. So this way we deleted the target node. And if it is not, if it suppose we want to delete d2 instead of d3, so what should happen is there should be some other conditions as well. So again the basic condition should be same. If a target node next to target node is not equals to null, obvious case, so what we should do is target node dot set next reference, we will just write set previous reference equals to null. Again we should so we should copy this one and we should move this out so that it's run for both the if condition, irrespective of condition, right? It should run. So that's why I move out, no need to write it again here. So if I will write again here, it's not the good way to write and write the code. Okay, now we have removed this d2 completely. Now we should do what is the pointer to the target node, which is d1 here. So pointer to the target node dot set next reference, set previous reference, no need, set next reference to the next node to the node next to the target node, which is this one, d3, node next to the target node, right? And then node next to the target node, which is this one, d3. So we should write it as simple as possible. Node next to the target node dot set previous, in this case previous reference, right? Set previous reference equals to node in the previous reference to this one, which is pointer to the target node, right? Just one previous to the target node. Yeah, pointer to the target node. So we have deleted this one, we have deleted here itself this node, and then this one set to this one, this one set to this one. And now do we need to change anything to the tail? No, we should not change anything to the tail. So what we can, is there any similarity in this one? No, no, and no. So we should just return head. So return head. Yeah, now this one is the complete logic for the minimum requirement of doubly linked list which we want to implement, right? I have removed this extra white space now. So this one we will be using for the LRU cache. So what we have used, remove element at the index. Removing, what we have done, we have started from the -1. I have told you the reason why, because we want to stop just one item, one node before the target node, and then what we will automatically reach to the next node. We will get the target node, we get the previous node of the target node, and node next to the target, and that's how we will delete. We will update the reference. If it's the last, we will update the tail as well, and then doubly linked list is with the minimum requirement is prepared. And now let's use this into the LRU cache. Thank you guys. Hope you will like this content. Yeah, so now the last part which is left is pointer to the so when it is removing from the head. So suppose this is doubly linked list, and there is we want to delete from the head. So there is data D, and then it is pointing to some other node, data D, and head is pointing to this, and now we want to delete this node. So what will happen is, this is a D1, let's say this is data D2. Okay, so head should point directly to the next, simple, and there should be no other change. So yeah, so let's write that logic. So this is the just one condition which should be there. So if so suppose index is 0, for that case index should be 0. When index is 0, index reached is -1, index is this, and -1 is less than -1 is false. So -1 is actually equals to -1. So it will come out of the loop, and pointer to the target node equals to custom node iterator. So yeah, then it which is head only, because it directly came out of the loop. So target node is pointer to the target node is head only, means head itself is pointing in that case, and target node will be, so for that case the target node will be a pointer to the target node is dot get next reference is target node will be the wrong case. So we should write some logic here instead of finding that if we are removing from the head itself. So in that case target node will be, because head is something which is pointing to this, so the condition will be, if we will do head means this node dot get next reference would be this one. So that case would be, so we should add here itself, if pointer to target node is equals to head, what we should do, and then let's point let this one point to some other node, or it's shall let it point to null, we don't care. So what we should do is, we pointer to the target node. Yeah, so this is the pointer to the target node, head itself is the pointer to the target node. In that case what we should do is it should go to the next reference. So head, this is head, should go to the pointer to the target node, which is head itself, dot get next reference, right, irrespective of if it's null or irrespective. And what should we do is, so head will point to the next one, and we should remove the elements as well. So how we can remove the element, pointer to target node dot set next reference equals to null. In this case we have to delete from the pointer to the target node, because that is the only node which we are deleting, and pointer to the previous target node dot set previous reference is equals to null, just for our it should be there, and we can move this logic into a separate code then. So and then pointer to the target node and pointer to the target node dot set and data equals to null, right? Now this logic, this three dots, this three lines, we should move it into some other piece of code. What we should write is public and unlink, let's say unlink custom node, right? We are totally unlinking it, making it so we can put custom node here, custom node, and then custom node, and here we should do custom node, and then here we should do custom node, and here we should do custom node. Sorry, I should do small custom node, here I should do custom node, and here I should do, so this way we should write the code. Now we have only, so return head where we were, yeah. So if pointed to the target node is head, then this is the starting node which we want to delete, and for that what we will do, which node we want to unlink custom node and pointer to the target node, right? That node itself we want to remove, because head is it, we want to remove the element present at head itself, so head should go to the next. We have moved head to the next and we have removed the itself, and then what we can do is return head, right? And this will unlink the custom node. Now yeah, same thing we are using here also, so we should do unlink target node. Here we should unlink target node, their target node was the node at the head itself, so unlink custom node, and then here we will do target node, right? Now it's look good, so let's okay, yeah, so look, this looks good, and this should be equals to null. And one more condition is we can remove this entire condition if we can think about more good way. Yeah, what we can do is we can check here if it's tail. So if it's tail, target node is tail, like this, just for the reference. If we are if we want to do in the good interview questions, you should do target node is equals to null, tail is there, right? Target node is equals to tail, then the same condition will be there. No need to go to do this all this, right? So target node is equals to tail and pointer to the set next reference, and tail equals to pointer to the target node, which is pointer to the target node, we have already discussed. So we can use this condition as well, just for the reference I have mentioned, and this should be equals to null. Yeah, so I think this looks good. And if yeah, so I have directly made the raw video. Will update anything in just please note into the description also if anything I have highlighted or anything special I have mentioned. Description will be always good to go as it will contain the summary. So and we will go again through all the items which we have gone through when we will be running the LRU cache. If any that time we will compile the code and we will fix any of the issue if we found there, but trust me, it will be most of the logic which we have covered is in the right way. So thank you friends, hope you enjoyed the way of how we should optimize our code slowly. How should we write the abstract things first, and then we should go to the next level, increment every level. So start from the basic minimum requirement write the abstract logic, go to the next thing. So hope that content you really liked, and yeah, we will meet in the next session for where we will be implementing the LRU Cache now. Thank you.